Imagine that the world you touch, see, and smell does not exist as such, but is only a set of perceptions. That is exactly what George Berkeley defended in the 18th century. For him, what we call matter had no real existence outside of being perceived. There was no hard wood without someone feeling it, nor a red color without someone seeing it. His famous phrase could be summed up as, "To be is to be perceived." At first glance, it seems like a strange mental game, but it holds surprising connections with scientific discoveries that would come much later at the height of quantum physics. In Berkeley's time, philosophy grappled between those who, like Descartes, sought absolute certainties, and those who, like Locke, believed that sensory experience built our knowledge. Berkeley made a radical turn. He held that everything we call the world is, in reality, a set of ideas that our mind experiences. He did not deny reality, but rather said, what is real is identical to what is perceived. To affirm the existence of an object independent of consciousness was, for him, nonsense. This perspective seemed pure metaphysical extravagance, but centuries later, it reappeared in laboratory experiments that challenged the classical notion of objective matter. If we think about quantum physics, we find a disturbing parallel. Electrons, for example, behave like probability waves until they are measured. As long as we do not observe them, we cannot speak of a defined position. Matter, at that level, does not exist as something solid and stable, but as a range of possibilities that collapse when an observer appears. Here arises the resonance with Berkeley, a world that depends on being perceived. What he proposed through philosophy, modern science shows with strange equations and world-famous laboratory experiments. The double-slit experiment is perhaps the most famous illustration. A particle, like an electron, moves toward a screen with two openings. If no one measures which slit it passes through, it behaves like a wave and draws an interference pattern. But if someone observes its path, it takes on the behavior of a particle and strikes a single spot. The simple act of measuring alters the result. It is the closest thing to Berkeley's intuition. Matter changes its nature depending on how it is perceived. The line between philosophy and physics begins to blur in a disconcerting way. Berkeley, of course, appealed to the idea of God as the guarantor that the world existed continuously beyond our perception. He said that although a tree is not being seen by you or me, it is still there because an infinite mind is perceiving it all the time. Quantum physics, for its part, runs into the same puzzle. What happens to reality when no one observes it? The debates on the Copenhagen interpretation, the many worlds theory, or quantum realism are attempts to answer that question that Berkeley asked himself long before electron microscopes existed. A curious detail is that for many years Berkeley's peers ridiculed him. His philosophy seemed like an exercise of imagination without any factual support. However, the 20th century showed that the microscopic world is far less obvious and far more mysterious than anyone thought. Max Planck, Niels Bohr, Werner Heisenberg, and Albert Einstein debated intensely about whether reality exists without an observer. Physics was forced to deal with problems that echoed the Irish philosopher's assumption, the dependence on the act of perceiving to give shape to what is real. But the disturbing part does not end there. Recent experiments with entangled photons show that measurement decisions instantly affect distant particles, defying all common sense. This invisible interconnectedness recalls Berkeley's proposal that what we call matter is neither independent nor self-sufficient, but part of a web of perceptions sustained by a mind. Today, that mind is described with another vocabulary, perhaps as quantum information or the global state of the system. But the essence of the mystery remains the same. Reality seems to adapt to how we question it. The most provocative part is that this coincidence is not superficial, but structural. When Berkeley denied matter, he was not denying tangible experience. On the contrary, he reinforced that the only undeniable thing is what is perceived. Similarly, quantum mechanics does not deny that we measure particles and obtain concrete results. What it questions is the permanence of those results beyond observation, just as Berkeley demanded in his metaphysics. What seemed mere philosophical speculation became an intuition eerily aligned with advanced science. Curiously, later philosophers such as David Hume and Immanuel Kant considered that Berkeley had gone too far. Hume saw his proposal as impossible to sustain in everyday life. Kant, on the other hand, took seriously the idea that we never access things in themselves directly, but only phenomena mediated by our perception. That legacy permeated centuries of debate. And when quantum physics exploded in the 20th century with unusual results, some thinkers dared to link those old philosophical dilemmas with laboratory discoveries. Meanwhile, figures like Einstein wrestled with this vision. He was deeply uncomfortable believing that reality depended on the observer. His famous statement that "the moon is still there even if I'm not looking at it" was a direct reaction against the implications of quantum mechanics. Interestingly, that claim was almost identical to the question Berkeley had resolved with his appeal to the divine mind. 2 centuries apart, the same intellectual challenge. Does anything exist independently of consciousness? The tension between what we see and what we believe there remains unresolved. If we translate all this into everyday language, it seems like an impossible puzzle. We live as if matter were stable and always present. However, experimental physics tells us that subatomic particles can exist in multiple states until they are observed, and Berkeley reminded us that speaking of wood or stone apart from perception makes no sense. Thus, both 18th century philosophy and contemporary science confront us with the same suspicion. What we call reality might be radically different from what we imagine in daily life. A simple example: when you dream, everything seems real while the dream lasts. Colors, sounds, textures. Does what you dream actually exist? No, but your mind perceives it as authentic. Berkeley would say that our waking life is somewhat similar, except that a divine mind maintains the consistency of experience. Quantum physics, in another register, also acknowledges that reality is not what we imagine as stable and fixed, but a malleable phenomenon. 2 completely different paths that converge in the same wonder at what we consider material. Today, quantum technology harnesses precisely those paradoxical properties. Quantum computing uses states of superposition, where a qubit can be 0 and 1 at the same time until it is measured. It is as if the machine worked thanks to that indeterminacy that depends on the observer. Unintentionally, Berkeley would inspire a powerful metaphor. No solid matter exists without perception. No defined data exists without measurement. The boundary between speculative philosophy and practical engineering advances has never been as blurred as in these contemporary developments. Thus, Berkeley's old suspicion that independent matter is a myth is unexpectedly reflected in the science that dominates the 21st century. Every time a laboratory demonstrates the power of superposition or entanglement, the echo returns of that Irishman who dared to deny matter. His thought and quantum mechanics are not the same, but they converse in a captivating language. Reality becomes strange, dynamic, and dependent on perception. A a constant reminder that the obvious can be the most seductive illusion of all.